Welcome to this video on expressions canceling, the do's and don'ts. This is actually an important topic because one of the most common sources of errors in problems involving algebra is inappropriate canceling. This comes out a number of places in Honors Algebra 3.4 and Pre-Calculus and Algebra 3.4. And I think the reason why is because I think a lot of times people are not sure when they should cancel and when they shouldn't cancel. So this video is all about knowing when it's possible for you to, quote, cancel something. There's really only two situations which can appropriately result in canceling something, okay? The first one is if terms are able to disappear because they add to zero. That's one way that we can, quote, cancel, is if things are summing to zero. And then the other one that we see more frequently is terms can be removed from a fraction because we're effectively able to factor something out and show that something over something is equal to 1, and so 1 times anything is that same thing, that's the identity, and so we're able to remove the fraction part that's equal to 1. Okay, so the trick to getting canceling correct is to only remove things from expressions if you can show how one of these two situations is true. So we're going to look at some examples here. There's a little bit of built-in practice, and then there's some practice sheets for you to practice this, because if you get good at canceling, you'll save yourself a lot of grief from doing things inappropriately. Okay, here's an example of the first situation, terms that disappear because they add to 0. If you're given this, this is actually an equation, okay, and you went on the left side to combine like terms, what you would find is that there's a term here that has 3x squared, and then there's a negative 3x squared, right? So you have 3x squared, and then you have a negative 3x squared, and then you have the rest of the expression on the left side, right? And because these two things are exactly identical, but one is positive and one is negative, when you add them up, they add to 0, right? So this is one case where it is appropriate to cancel, because you can show that two things are adding to 0, right? So that's one case. And that case is not too bad. That's fairly obvious if you can when you combine like terms. The other case is the one that's trickier, okay? So this one is when terms can be removed from a fraction because they're equivalent to multiplying by 1. Let me show you what I mean with just fractions. This is the same procedure you use when you're simplifying fractions. If I have this fraction 30 over 25, I can factor out the same number from both the numerator and the denominator. Both 30 and 25 are divisible by 5, and so I can show that the top is 5 times 6, and the bottom I can factor out a 5 and say it's 5 times 5. Okay, well, this 5 over 5 right here, this 5 over 5 right here is really the fraction 5 over 5, which is 1. In fact, I could actually write it as a separate fraction. It's the fraction 5 over 5 times the fraction that's left, 6 over 5. But this fraction over here is equal to 1. And so 1 times anything is that thing, and so that's why it's okay to cancel them out, right? I shouldn't really even be using the word cancel, but I must admit, like most students and teachers, I do use this word canceling. I use it in some of the videos that you'll see in this series too. But when I draw a 1 through something like that, what I'm really saying is that that 5 divided by 5 is a 1, and therefore I can remove it from the fraction because it doesn't do anything to the fraction. What's left, it's 1 times what's left, okay? So if I was going to show that that's what I'm doing when I'm simplifying this one on the right side, x to the 4th divided by x squared, I could say, well, you know what? I can factor an x squared out of both, because x to the 4th is the same as x squared times x squared, and then x squared is x squared times 1. And that means that this fraction on the left, x squared divided by x squared, is a 1. So we have 1 times x squared over 1, which is just x squared. Okay? That's the only appropriate way that you can cancel something, is if you can show that you're able to factor something out from the entire numerator and the entire denominator so that on one side it forms the fraction 1. And then you can remove that 1 because multiplying by 1 doesn't change the value. Okay, let's take a look at a few more examples, and you can try some of these. What do you think about this one? 2x plus 6y over 2x. What would you do if somebody said to simplify? Pause the video, try it, and then unpause. Okay, I can hear you guys thinking out there. I know that some of you did this. Right? Some of you did that and said that was equal to 6y, okay? Well, that's actually incorrect. That's actually incorrect. We do not want to do that, okay? The reason why, in fact, let me write it over here. Let me write that over here. 2x plus 6y over 2x. Okay, why do we not do this? Well, the reason why is we didn't form a fraction because that 2y, or that 2x, is not a part of the entire numerator, right? We did not do that. So I'm going to put that there and say that's one of the biggest mistakes that we see in algebra class, people doing that kind of cancellation. Instead, here's what you can do. What can I take out of both the top and the bottom? The only thing I can factor on the top is the number 2, right? It's 2 times x plus 3y on the top if I factor a 2 out. And then on the bottom, I can take that 2 out and it leaves an x. And so really the only thing that I get to cancel is the 2's, because 2 divided by 2 is 1. And then that leaves me this fraction, x plus 3y over x. So that's the correct simplification. And again, you can't cross off those two remaining x's because the x on the top is only a part of the numerator. All right. Using that one as an example, see if you can get this one correct. What's the correct way to cancel here? Okay, so the correct way is not to cross off the 3x and make the bottom 3x or 3 or something like that. The right way to approach this is to say, what can I take out? Well, I've got an x on the bottom, but I don't have an x in the entire part of the top, so I'm not going to be able to take that out. But I do have 3 numbers here, and they're all divisible by 3. That suggests I can remove a 3. If I remove it from the top, I factor it out, I would have x plus 2y left. And if I remove that 3 from the bottom, I'd have 3x left, right? And then that means that I can cancel the 3 over the 3 because that's a 1, and I'd be left with x plus 2y over 3x. That's the correctly fully simplified form. Okay, let's look at some more complicated examples. What about this? Pause it, give it a shot. Remember, try to factor the same thing out of the numerator and the denominator. Okay, let's see. Well, number-wise, it looks like I might be able to take a 3 out, so I'm going to start with that. What about a? Do I have an a in all the terms on the top and all the terms on the bottom? I do have a's, but it looks like I'm limited to taking a single a out. And the same thing, I can take a single b out. So let's do that from the top. If I factor out a 3ab from the top, I'm left with one more a here. Plus 2 times, and then there'd be a b here. If this is kind of mysterious to you, you can jump down to the portions on factoring and look at the factoring introduction greatest common factor video. That explains this process that I'm doing here. Okay, I would like to take that same 3ab out in the denominator. So let's say I would be left with a 5 here, and that'd be the only thing I have left. Okay, and that means that 3ab over 3ab, this is the fraction 1, so it goes away, and I'm left with a plus 2b over 5. All right. Here's another one. What's in common here? Well, I see this quantity 2a plus b. Let's not do distribution on the top or anything like that. How about if I just factor out a 2a plus b on the top? It's already factored, leaving a 2a minus b. And on the bottom, what if I think about factoring that out? What's left? Some people think there's a 0, but actually there is 1 2a plus b, so there's a 1 left. It's that times 1. And that means this fraction goes away, and I have 2a minus b over 1, or just 2a minus b. 2a minus b. That's why that cancels. Okay, another one. Same idea. It looks like I have a quantity with pluses on the bottom, but I don't have the numbers to match. But I could factor a 3 out on the bottom. Let's do that. On the top, I'm going to leave that 2a plus b, 2a minus b. But on the bottom, I'm going to factor out a 3 so that I get 2a plus b, right? Because 3 times 2a would be the 6a, and 3 times b would be the 3b. And that forms 2a plus b over 2a plus b, so that's a 1. And I have 2a minus b all over 3. All right, that would work. Okay, just to summarize, you can only cancel in a fraction if you're able to factor out something from both the numerator and the denominator such that that is the same thing on the top and the bottom, so that you're really multiplying what's left by a fraction of 1, and so then you can remove that 1. You can also, it's helpful, I think it's helpful to explicitly show that factoring. Show that you can factor out the same thing on both sides of the fraction before you quote cancel, right? And you can also remove things that sum to 0. But we mostly get confused about the first case. Okay, give the practice pages a try here so that you can remove this error from your repertoire. So many students make this error, and it causes a lot of problems. So the quicker that you get proficient at this, the better.